Good morning. My name is Sudhakar. So we are discussing about the basic manufacturing technology in that third chapter, shaper, slaughter, planer. Right. So in this shaper, slaughter, planer, we have completed so far about the shaper and slaughter. Right. Okay. So in the shaping mission and slotting mission, we have completed so far in the previous class. Learned about the slotted driving mechanism, feed mechanism of slaughter, operations on slaughter, work holding devices. So these have been discussed in the previous session. Right? So once again, we can recall what is shaping and what is slaughter. Shaper is a reciprocating machine and it is used to produce the flat surfaces, whereas slotting machine also having the reciprocating motion. It is also used to produce the flat surfaces, but the difference between the shaper and slotter is shaper is in horizontal direction and the basic shaper is in horizontal direction and the basic slotter is in vertical direction. Okay, so we have vertical shaper also, but what is it? So it is similar to the slotting machine. The vertical shaper is similar to the slotting machine, but the difference between the slotting and vertical slotter and vertical shaper is the tool head is rotated with some angle in vertical shaper, but whereas in slaughter it does not tilted. Sorry, this does not tilt it with any angle. Okay, so the work table is having the rotary action. So this is the basic major difference between the shaper and the vertical shaper and slaughter. Right. The rest of the things are similar. What is happening in shaper machine, vertical shaper machine, and the slaughter machine are similar. Only the thing is the tilting angle of the thing is the difference, right? So after that, we have discussed the driving mechanisms of both of the shaper and slaughter, with the quick mechanism and trans-slotted lever mechanism and hydraulic motion mechanism. Right? With these mechanisms, what we have achieved is the cutting stroke should be minimum. Cutting stroke should move at minimum speed, and the return stroke should be at faster rate. Why? Because to increase the production rate. So cutting stroke we are using that is for the removal of the material, and the return stroke is like is an radial stroke where there is no metal removal, right? So that's why we are providing the return stroke should be fast. So that's why we are increasing the production. Okay, these are the things I have covered in the previous class, right? So now we are moving to the another machine, that is the planer machine, right? So on the completion of this period, we are going to able to know about the what is the planer machine and explain its working principle and classification of planers, right? By planer machine and its working principle and classification of planers. That is going to be discussed in today's session, right? So far we have covered the shaper and the slaughter. So, with remembering that two machines working principles and work holding devices and a line of action. So, from that two machines, so we have easily understood this planar machine. What is the planar machine and what is its working principle? Okay. So, and types of planes, right? So now we are moving to the what is a planar machine. Okay. So in earlier lessons, before going to discussing about that, what we have observed in the two machines that have to be recalled now. in the earlier lessons, that means either lathe, coaching, or shaper, slaughter. Okay? We learned that the tool moves and work is stationary. Okay? Compared with the shaper and slaughter, not in the exact of the lathe. In the lathe machine, the workpiece is rotated, not in fixed position. Whereas in broaching, the workpiece is fixed and the broaching tool may be move or the cutting tool is uh, fixed and the workpieces may be moved. So we have to compare with these two, shaper and slaughter. So in the earlier of this our topic, what we have learned that the tool moves and the work is stationary. The tool is moving and the work is fixed in some position. Okay, that we have observed in our earlier lecture, right? So in a shaper, the tool reciprocates and the work is stationary. And we know already that in shaper machine, the tool reciprocates and work is stationary. So it is produces flat surfaces. So do you know a machine in which tool is stationary and the table holding the work moves? Here we are going to know about the new machine. In that machine, what happened? The work table is moving. The work table which is holding the workpiece is moved, and the cutting tool is at a stationary position. Okay, so observe this point here. The work table which is holding the workpiece is moving. It is moving, but the cutting tool is at a stationary position, right? The cutting tool is at a stationary position. So that is the mission we are going to discussing today. That in a shaper, the tool reciprocates and the work is stationary. But here the work is moving and the tool is stationary. So what is that mission? Undoubtedly, we can tell that one of such important mission is a planing mission. We can tell that it is a planing mission. This is the basic interview point of question, right? As many of the interviews, they may ask what is the difference between the shaper and planer. We can easily tell that in a shaper machine, work is stationary and the cutting tool is moving, whereas in planer, the cutting tool is stationary and the workpiece is moving. That has to be the main difference in shaper and planer, right? That is the planing machine, right? And the animation also we can get in another slide. So here we can observe these are the cutting tools, tool holders. Here the tool cutting tools are fixed here, and where has the workpiece is fixed here on this table. So this table, on this table, the workpiece is rotated or moving. Sorry, not rotated. It is moving on this table, and the cutting tool is at a fixed position. So by this, getting the we are getting the flat surfaces or machining action. Okay, this is the basic diagram of the planing machine. In the diagram, we have observed that the table on this table, the workpiece is fixed, and the cutting tools are at a fixed position, and the workpiece is moving on this table. So by moving of this, the cutting tool is doing the manufacturing operation, right? So metal removal has been taking place. So that we have discussed in detail in our coming lecture, right? So what we tell that planing machine, the workpiece is moving and the cutting tool is stationary. So compared to the slaughter and shaper, right? So this is another view of the planer also. So the table is at highest position and the machine occupies idle space that we have diagrammatically we can tell that. Yep. So in the animation action, we have observed this. Right? The table is moving. Right? We have observed in the diagram. The table is moving. The table is moving, and the cutting tool is at a fixed position. So on this table, the workpiece is fixed, right? So with the movement of the table, the workpiece is having the movement, right? So the cutting tool is doing the manufacturing, okay? That have been observed in the animation. In this animation also, we have observed that the table movement of the planer. The cutting tool is fixed at one position that we have observed in the diagram. Right, so we are entering into the what is a planer. It is a machine which produces the flat surfaces. A planer is a machine which produces flat surfaces. As we know, compared to the shaper and the slaughter, they are producing the flat surfaces. Understood? They are producing the flat surfaces, and we learned that here also it is a machine which produces the flat surfaces, and it consists a stationary housing for holding the tools. Here, the one thing is a stationary housing is there, as we have observed in the diagram. In that stationary housing, we are fixing the tools. We have fixed the tools. Okay, so the table holding the work reciprocates. Here, the table is reciprocated. Understood? We have observed in the animation also. We have seen the table holding the work reciprocates, and the cutting tool is at the tool is stationary, but the work is moving, right? So we have observed in the animation also in this direction, in this action, we can easily understood what is happening in planar. So the cutting tool is in the vertical direction, and it is a fixed position, and the workpiece is fixed on the table. So the workpiece is reciprocate under the tool. The workpiece is reciprocates under the tool that we have observed. The table on which work is clamped is imparted a reciprocating movement. The table on which work is clamped is imparted a reciprocating movement. Cutting takes place during the forward stroke of the table, and during return stroke, the cutting tool is slightly lifted. So, tool is fed for each forward stroke. Okay, here also the cutting takes place in the forward direction, and in the return stroke, the cutting tool is slightly lifted. The tool is fed for each forward stroke. Tool is fed for each forward stroke. So, similar to the shaper, right? The cutting stroke is taking place in forward direction, and in the return stroke, there is no cutting action takes place. It is an ideal stroke, as we have learned in our earlier machines also. So, for that reason, what happened here is the tool is lifted in the return stroke. So, the tool is lifted. It may not touch the workpiece because the workpiece is continuously reciprocates. Okay, its action is continuously reciprocate. There is no change, or there is no feed, or there is another motion. So what we have to do is just we have to lift the cutting tool when the work is coming backward, right? So for that reason, the cutting tool has to be slightly lifted when return stroke is happening. Okay. So these are the working principle we can easily understood by this animation. And here the table is driven by an electric motor, whereas in a shaper the cutting tool is moved by an electric motor. Here also table is driven by an electric motor. And here the length of table stroke can be adjusted. So the length of stroke means we have to cover the where the actual work has to be done on the workpiece. So for that we have to adjust the length of the stroke. Whereas in a shaper we learned that the based on the cutting stroke we can give the 20 length more than the cutting stroke. Understood? So that is the adjustment. So here also, suppose 10 length is we have to do the flat surfaces. So we have to give 30 length of the length of stroke. So that has been discussed in our shaper motion. Okay. So here length of table stroke can be adjusted and the speed of return stroke is also regulated. Same like shaper, speed of return stroke also regulated. That means return stroke should be faster compared to the forward stroke, because in forward stroke the cutting process has been taking place, whereas in return stroke the cutting stroke is not done. It is an ideal stroke. So for that reason, speed of return stroke is also regulated. So these are the principle of operation of a planer, table and work travel. We have observed in the diagram, and the tool is feed. So here feed is given to the cutting tool only. Feed is given to the cutting tool. Whereas feed is given to the workpiece and the reciprocating motion to the cutting tool in shaper. In planer, the feed is given to the cutting tool and reciprocating motion given to the workpiece. Okay, so that has been observed in this diagram and in reciprocating motion. Classification of planers: 1. Double housing planer. 2. Open side planer. 3. Pit type planer. 4. Edge planer or plate planer. 5. Divided planer. Okay. So double housing planer is the standard model and most widely used, and it is very heavy and robust. Has a bed and two vertical housings are fixed. Table moves along the guideways of the bed. Housing supports cross rail and tool heads. Cross rail carries tool heads. Tool head carries tools. Okay. So this is the double housing planar machine. What we have observed in this diagram. So this is the standard model and most widely used. Very heavy machine and it is very robust. As a bed and two vertical housings are fixed. So these are two vertical housings, 1 and 2. These are two vertical housings. Table moves along the guideways of the bed. So table moves. This is the work table. So along this guideways, the table is reciprocated here, right? Housing supports cross rails and tool heads. So these are two cross rails here. One is this is cross rail and it is cross rail. On this cross rails, tool posts are fixed. On this tool post, the tool heads are fixed. Okay, so these are two houses. That's why it is called as a double housing planer. The table is moving on the guideways of this table, and the housings attached with the two cross rails. On this cross rails, two work holding devices, two cutting tool holders are there. On this tool holders, the cutting tool is tool carriers, the tools. Okay. Open side planer. It has only one supporting column housing. Okay, whereas in that only double columns are there. Here double housing is there. Here only one housing is there. Area larger than the table can be plain. Cross rail is mounted as a cantilever. Tool holders are mounted on cross rails. Okay, so it is looks like a cantilever base because one side is fixed and another side is open, right? Pit type planer. So it is columns and cross rail carrying tool head move longitudinally and massive rail supporting the table. So bed is recessed in the floor. Loading and unloading jobs easy, used for planing. Heavy and large jobs, table and workpiece resting on it are stationary and the tool reciprocates. Okay, so this is the pit type planer. What happens in columns and cross rails carrying tool head move longitudinally and massive rail above the work table. Bed is recessed in the floor. The bed is in the floor. So with this we can easily loading and unloading of the job. So the name itself pit. Pit means it is in the floor. So that That's why loading and unloading objects is easy. So this can be helpful for us for heavy and large work jobs. The table and workpiece resting on it or stationary and the tool reciprocates. Edge planer, specially designed for squaring or beveling the edges of heavy steel plates for pressure vessels. And its carriage supporting the tool is moved back in the front direction. Cutting can take place during both directions of carriage travel. In this edge plate planner, the cutting can be takes place during both directions of the carriage plate travel. Operator stands on the platform and operates. So this is the HR plate planner. This is used for bevel edges, squaring of bevel edges, squaring or bevel edges, beveling of the edges. Okay. So carriage supporting the tool is moved back and front direction. Cutting can take place during both directions of carriage and front. Operator stands on both on the platforms and operates. Divided table planner, also known as a tandem planner. Planer has two tables on the bed. The table may be reciprocated together or separately. Each table reciprocates under different tool head. For continuous production, small workpieces clamped on one table are being machined. Another is stationary and can be used for setting up test box. So this is used for quick and continuous production. So it is a tandem planner. It has two tables on the bed, and the table may be reciprocated together or separately. Each table reciprocates under different tool heads. So it is used for quick and continuous productions operations. Okay. So based on coming to the construction of planer and functions of the parts, specifications of plane. Okay. So planing machine parts, bed, table, tool heads, column, crossride, feed mechanism. Okay. So these are the parts, main parts of the planing machine. Okay. So in this one is the better and the table, housing a column, crossride, tool heads, driving mechanisms, and the feed mechanism. So these points are covered in our shaper and slaughter also. They are also having the functional details and they are having the parts of the machine. Okay. So in all the parts, what we have learned, the bed is the main base of the machine. Okay. For all the machines, the bed is the base of the machine. It can holds all the parts of the machine, and it houses for different lubricating. It houses the lubricating oils. Okay, so that is similar to all the machines point. If it has the base of the that is the base of the machine. Okay, so in this diagram we have a curve. So these are constituent parts of planer. So up to this point, it is a large box like casting. That is the large box like casting, and its length is nearly twice the table. The length, its length is nearly twice the table. So it consists of guideways on which the table moves. Houses the driving mechanism of the table, and it is made up of cast iron because all the other parts of the machine are situated on this bed. But here the thing is, it houses the driving mechanism of the table. Why we can tell that we know already the function, the working principle of the plane. Okay. Here the table is moving and the workpiece is cutting tool is at stationary position. So for this, the bed is like a box-like structure. It is made up with casting, okay, and its length is nearly twice the table length. Bed length is nearly twice the table length. Why? Because on this bed, the table is reciprocated, right? On this bed, it is having the guideways. So on this guideways, the table is moving, reciprocated. Why the table is moving? Because on this table, the workpiece is fixed. So here the working principle is working. Uh, Workpiece is moving and the cutting tool is stationary. So for this reason, the length of the table is nearly twice the table length, and it consists of guideways on which the table moves, and it houses the driving mechanism of the table, and it is made of cast iron. So it also holds the driving mechanism of the table. With that driving mechanism, the table is having the reciprocating motion. So for that, it is made of cast iron. So the bed is the main part of in the planar machine. Okay, the table. Okay, so on the bed, the table is situated. Okay, also called as a platen. Here, the table is also called as a platen. It is a large rectangular casting mounted on bedways. It is a large rectangular casting mounted on bedways, and it holds the work and reciprocates along the bedways. So on the top surface of the table, it is having the T slots. Why? Because providing the T slots, as we have observed in the shaper and the slaughter. With this lead, T slots, workpiece is clamped. So the workpieces will not get any vibrational effect during the machining operation. So for that reason, we are providing the T slots of the on the top surface of the table. Okay, on this T slots, the work is clamped. So it is a large rectangular casting mounted on bed base. So its length is half the length of the bed. Okay, on this table we can hold the workpiece, and it is reciprocates along the uh, bedways or guideways of the bed. Okay, so this has been we have covered. And housing or column. So it is a large structure, large vertical structures on each side of the bed. So, housing or column are large vertical structures on each side of the bed, as we observed in the types of planar machines. Okay, housings are large column structures, and they are on both sides of the bed, and it supports cross rail on which tool heads are mounted. Also supports the mechanism for operating the tool heads. It is made of cast iron. So housing or column, large vertical structures on each side of the bed, supports cross rail on which tool heads are mounted, also supports the mechanism for operating the tool heads. So this column supports the mechanism for operating the tool heads. So it is made of cast iron. Cross rail, a rigid casting mounted horizontally on the column, and it can be moved up and down by elevating screw. So it can be moved up and down for the adjustment for the width of the workpiece. Okay, for that reason it is having the up and down movement. So it can be controlled by the elevating screw. It is a rigid casting, and it is in a horizontal position, and it carries two slides with tool heads. Okay, the cross rail is carries the two slides with tool heads. Tool heads can be moved horizontally on the guideways of the cross rail. These tool heads are which are moving horizontally on this cross slides. Okay, tool heads. It contains tool posts for holding the tools, Tool post is hinged to the head. During return stroke, the cutting tool will be lifted, and we learned that tool heads can be swiveled to 60 degrees on either side of its vertical position. Okay, so these are the constructional details of the planar machine. Right now, we are moving to the specifications of a planar. Here, what we have to keep in mind is the distance between the two housings, because the workpiece width and it has to be freely reciprocated between the columns. So that's why distance between the two housings and the height between the table and cross rail at its uppermost position, and the maximum length of the table travel, number of feeds available, and power input, floor space required, type of drive, net weight of the machine. These are the points have to be keep in mind and going to purchase the planar machine. Distance between the two housings, and what are the things we need in our workshop and for our manufacturing purpose. So we have to keep this mind and going to buy this planar machine. Okay, height between the table and cross rail at its uppermost position, maximum length of the table travel, number of speeds and feeds available, power input, floor space required, and the type of drive, net weight of the machine. Okay. Now we are moving to the driving mechanisms of the table. Okay, in this planar, the table is moving and the cutting tools are at fixed position. Right? So in this, we are having the three belt drive mechanisms are there. Principle of open and cross belt drive mechanism, reversible motor drive mechanism, and working hydraulic drive in a plane. So before going to set the driving mechanisms of the planer, first of all we have to keep some of the points in our mind. What are the points? A planing machine produces flat surfaces, right? And here the table holding the workpiece reciprocates, not the cutting tool is reciprocated. Here the table holding the workpiece reciprocates, and there should be some mechanisms to move the table in reciprocating motion. There should be some mechanisms to move the table in reciprocating motion, and the table is to be moved quickly during the ideal stroke. Okay, so these are the points you have to keep in mind. Right? The planing machine produces the flat surfaces. The table holding the work reciprocates, and there should be some mechanisms to move the table in reciprocating motion, and table is to be moved quickly during the ideal stroke. Okay. So in that, what are the mechanisms are open and cross belt drive, reversible motor drive, hydraulic drive. Okay. In that, the first one is open and cross belt drive mechanism. First of all, we have to observe the details of the mechanism. One is loose pulley, second one fast pulley, third counter shaft, four pulley, and five pulleys on shaft, and six open belt, and seven cross belt. Eight is the shift belt, and nine and 10, 9, 10, 11. 9 and 12 are the loose pulleys, and 11 and 10 are the fast pulleys, and 13 pull gauge shaft, 14 pull gauge, and 15 is the rack. With this rack and pin arrangement, the table is moving, and 16 is the feed disc. Okay. And 17 is the belt shift lever, 18 is the tip dog, 19 is the T slot, 19 is the cable, and it is having T slots. Right? 20, 21 are the bull gauge change gates, and the 22 is the shaft, 23 is the shaft, 24 is the gates, 14 and 13 are the full gauge shaft, and 14 is the full gauge. Okay, gauge change gates. And these are the arrangements we have observed in our open and cross belt drive mechanism. what happened here? It is used for small capacity machine. Open and cross belt drive mechanism is used for small capacity machines. In this, the table is moved by gates and rack attached under the table. So under this table, rack and pinion is attached with there. With that, the table is moving. Okay, and the counter shaft at the top of the housing has two pulleys. Counter shaft. Where is the counter shaft? Here, the counter shaft. It is having the two pulleys. Okay, uh, fully transfer power to the main shaft. From here, the power is transferred from here to here, here to here. With this press, power is transformed from here to here. Right? Main shaft drives the table by rack and pinion. Main shaft, where is the main shaft? That drives the rack and pinion. That drives the rack and pinion. And whereas the counter shaft, two sets of fast and loose pulleys are mounted on driving shaft. Smaller fast pulley is used for backward motion of table, hip motion, and it is connected to by the open belt drive. Smaller fast pulley is connected to the smaller fast pulley is connected to the used for the backward motion of the table, and it is connected by open belt drive. And the bigger fast pulley is driven by cross belt drive. It is used to drive the table during the forward stroke. Open and cross belt drive mechanism. At the end of cutting stroke, the cross belt is shifted from fast pulley to loose pulley. At the end of cutting stroke, the cross belt is shifted from fast pulley to loose pulley. Simultaneously, open belt is shifted from loose pulley to fast pulley. So this is achieved by trip dog, which operates belt shifting lever. So thus the direction of movement is automatically reversed. So this is the rack and pinion arrangement. It is under the table. So this arrangement used to move the table in the open and cross driving mechanism. Now we are moving to the another motor drive mechanism, reversible motor drive mechanism. In this, electric motor drives the bull gear to gate rails. Motor is coupled to DC generator. When the motor is started, generator supplies power to a reversible motor. Reversible motor causes the planar table to move. At the end of stroke, trip dog operates the switch which reverses the direction of the table. So speed of cutting stroke is reduced by regulating the field of the current to the generator. Okay. This is the reversible motor drive mechanism. Electric motor drives the bull gear to gate rails. Motor is coupled to DC generator. When the motor is started, generator supplies power to the reversible motor. Reversible motor causes the planar table to move. At the end of stroke, trip dog operates the switch which reverses the direction of the table. Speed of cutting stroke is reduced by regulating the field of current of the generator. Okay. And now the last one is the hydraulic drive planer. This is observed in our shaper machine also for driving the ram. Okay. Here, what happened? The same like shaper during cutting stroke, oil is pumped into the left hand side of the cylinder. Left hand side of the cylinder. So this is the left hand side of the cylinder. Is the area is less due to presence of piston rod. Here, what happens? The area is reduced because of this presence of piston rod. Less force acts on the piston. Okay, so the table moves slowly in cutting stroke. So with this, what happens? The less force is acted on the piston. So for this reason, the table is moving slowly in cutting stroke. At the end of each stroke, trip dog operates a lever. So lever actuates the control valve of the circuit. So at the end of each stroke, trip dog operates a lever. Lever actuates the control valve of the circuit. So oil is pumped into the operating cylinder. The cylinder contains piston and piston rod. So the other end of the piston rod is connected to the table. So during return stroke, oil is pumped into the RHS of the cylinder. So the more force acts on the piston and it moves quickly. In the simple words, we can tell that the more force acting on the right hand side, the return stroke is fast, and the less oil is less force is acted on the LHS side, so the slow movement is there. because the piston rod is present in the LHS side. Okay. Hydraulic drive of a planer. Flow of oil is changed from one side to the other side of the cylinder. The length of stroke can be varied by adjusting the distance between the tip rods. Okay. So these are the drive mechanisms in the planer machine to drive the table. So open tilt and cross drive mechanism, reversible motor driving mechanism, and hydraulic drive. Now we are moving to the operations performed on the planer machine. Okay. So planar operations are similar to those performed on a shaper with a difference that the workpieces are much larger in size. Okay? So here the operations are same as in shaper, but the difference is that the workpieces are much larger than in size compared to the shaper. Yeah, so here the working principle is same. Working principle is different, but the operations performed are same. Okay. Planar operations, planing horizontal surfaces, planing vertical surfaces, planing angular surfaces, that is sockets, planing curved surfaces, planing slots, and grooves. Okay. So in the planing horizontal surfaces, what are the steps involved? Fix the workpiece properly on the table, set the required cutting speed, give required feed of the tool, give suitable depth of cut for rough cuts, finishing the job by giving less depth of cut. Okay? So these are the steps involved while doing the horizontal surfaces. Fix the workpiece properly on the table, set the required cutting speed, and give the required feed of the tool, and give suitable depth of cut for rough cuts, and finishing the job by giving less depth of cut at each row. Okay? So in animation, we have observed that only the thing is changed, the workpiece is reciprocated, and the cutting tool is fixed at one position on the tool head. Okay, the workpiece is reciprocated. Planing vertical surfaces. So similar animations, but the difference is the workpiece is rotated. Workpiece is reciprocated. Fix the job on the table only. Align the surface to be machined properly. Vertical slide is adjusted perpendicular to the table. Swivel the apron away from the job. Switch on the machine. Rotate down, feed screw by hand to give down feed. So here also fix the job on the table only. Align the surface to be machined properly. Vertical slide is adjusted perpendicular to the table. Swivel the apron away from the job. Switch on the machine. Rotate down feed screw by hand to give down feed. So here we are adjusting this slide. So it is used to measuring this surface, planing vertical surfaces with this planar machine. Okay, so the cutting tool is in position. The work table is more like this, and reciprocating motion. Okay, planing angular surfaces. Steps involved in angular surfaces. Main angular planing is to make dovetails and V-grooves. So with this, we can angular surfaces are they are dovetails and V-grooves. To set the work on the table, swivel the tool head to the required angle, set apron away from the work, give down feed as per requirement. Okay? So main angular planing is to make dovetails and V-grooves, set the workpiece on the table, swivel the tool head to the required angle. We have to swivel the tool head to the required angle, set apron away from the work and give down feed as per requirement. So as we have observed these diagrams in the shape are also of the right in the nesting operations. Planing for form surfaces. Fix up a square nose tool in tool head. Required form is obtained by feeding the tool simultaneously in both horizontal and vertical directions. Give suitable depth of cut. This can also be done with the aid of a special fixture. Observe here. Formed surfaces like concave and convex surfaces. Okay, for this fix a square nose tool head in tool head. Required form is obtained by feeding the tool simultaneously in both horizontal and vertical directions. So give suitable depth of cut. So this can also be done with the aid of a special fixture. So that is the planing formed surfaces. Okay. So that is observed in the animation planing formed surfaces and planar cable. Planing slots and group. So fix up the job in the table suitably. Fix a slot of tools and tool heads. So we have to do the slots on the workpieces. So slot of tools have to be fixed in the tool heads. And give feed using down feed screw. Move the tool by the required amount to get the uniform slots and groups. Okay. So with this we have to fix the slotters in the slot tool and give the feed to the slotters, and it requires give feed using down feed screw, move the tool by the required amount to get the uniform slots and tools. Fix up the job on the table suitably. Fix the slaughter tools in the tool heads. Give feed using down feed screw. To move the tool by the required amount to get the uniform slots and tools. Okay. So let us summarize what we have learned today. So with this, we have completed the operations performed on the planar machine. So today in this session, we have completed the planar machine. First, we have learned that what is planing machine, how it is different from the shaper, and after that, we have discussed the working principle of the planing machine as compared to the shaper. Here, the shaper machine is having the workpieces fixed at the cutting tool is reciprocated, whereas in planer, piece is reciprocated, the cutting tool is fixed at one position, right? And after that, the construction details of the planer. What are the parts it is having? Base, tool head, work table, cross rails, and housings, etc. These are the work construction details of the parts of the planer machine have discussed. And after that, the types of planer machines have also discussed. The right types of planer machines have learned here. And after that, the driving mechanisms which are used to drive the cable of the planer that has been discussed while doing the machining operation. The table, how the table has been moved, okay, that has been discussed. Right? And after that, the operations performed on the lathe planing machine. Okay. With this, I am concluded that the third unit is planer, shaper, and slaughter has been finished. Okay. With this knowledge, we can do some quiz questions. For machining angular surfaces, what should be given to the required angle? Vertical slide. Work can be fixed on the table directly using clampings and keyboards. The main angular planing is to make cutout heads. Okay. So with this, I am concluding the third unit and closing today's session. Thank you.